graph analysis application of what we're doing. And I want to show you a couple of different graphs so that you have a feel for what the different graphs tell you. In this case, the graph shows the velocity. So this is already the first derivative on this graph. So everything above the x-axis is a positive slope representation. And everything below the x-axis is a negative slope representation. So if you actually knew what the position function was, and you could take the first derivative and look at it at different values of x, this is the graph that you could make. Only they've already made it for you, and they're giving it to you in a graphical approach. So, question 6 says, when is the particle moving right? Well, the particle is going to move right when v of t is greater than 0. That's any time that the graph of v of t is above the x-axis. So I see it above the x-axis here from 0 to 1. It's an interval from 0 to 1. And here from about, I'll call that 4.5 to 7. So those are the pieces of the graph that are above the x-axis. So that is when the particle is moving right, because the velocity is positive. When is the particle moving left? That's when the velocity is less than 0. So where is it below the x-axis? Well, that's the other stuff. That's the 1 to 4.5. Number 8 says, when is the particle's acceleration positive, negative, or 0? Now think about acceleration. When we know v of t, that's the first derivative of the position equation. So when we want to find acceleration, that means that we're looking at the derivative of v of t, or the second derivative. So in looking at this graph, we can actually look at the slope of v of t. I'm going to write that over here. Slope of v of t. And see when it's positive or negative or whatever. So let me do a little erasing here real quick. Here we go. If you look at this first part of the velocity, that is a negative slope. So acceleration is going to be less than 0, where the slope is negative. So from 0 to 2, and right here, from 6 to 7. Negative slope. When we talk about positive slope, this is the piece we're looking at. This is where the acceleration is positive from 2 to 6. And let's see. I don't think it's 0 anywhere. Yeah, we don't have any 0 slope anywhere. Now, where does the particle have the greatest speed? Well, remember, speed is the absolute value of velocity. And you already have the velocity, which is helpful. So what you want to do is you want to look at all of your y values. So I have a y value, let's see, down here at -2. That's, if I took the absolute value of -2, that would be 2. And here I have a y value of +2. So our particle has the greatest speed at 2. Any of those, at either of those points. So at 2, -2, or at 0, 2. When is the particle speeding up? Okay, so I'm slowing down. So what I did for this one, I actually made myself like a little chart, and I plotted it out so I can look at the signs, compare the signs. And I made intervals along this chart. So 0, 1, 2, and then I jumped over to 4.5 because that's where the graph changes. And then 6, and then 7. So what I'm going to do is I'm going to go through and I'm going to record all the signs, positive or negative. And I'm going to say, okay, from 0 to 1, the velocity is positive. From 1 to 4.5, my apologies for that, it's negative. And from 4.5 to 7, the velocity is positive. And we did that in question 6. And then the acceleration, from 0 to 2, it has a negative slope. From 2 to 6, the acceleration is positive slope. And from 6 to 7, negative slope. So what I want to do for speeding up, I want the signs to be the same. So where are the signs the same? Well, they're the same here, 1 to 2, and here, from the 4.5 to 6. Now, let's see. Where's the particle slowing down? Well, that's where the signs are different. So that's everywhere else. I'm going to draw myself a little arrow out here. It's going to be from 0 to 1. It's going to be from 2 to 4.5. And it's going to be from 6 to 7. So that's how we do a problem like that where we're given velocity. The other one that I wanted to show you was what happens when we're given position on a graph. This is the actual position function. So what we need to do is we need to kind of adjust our thinking. This is not slope you're looking at here. Now that doesn't mean we can't calculate slope or look and see, is the slope positive or negative or 0? But this, the red line, not slope anymore. These are function values. This is the position function. So for part A, where is P moving to the left? Well, that's where the velocity is negative. That's where we have negatives. And we can easily look at this graph and see negative slope, negative slope. So from 2 to 3 and 5 to 6. In part B, when is it moving to the right? Well, it's the opposite. When V of t is greater than 0, or we have positives. So let's see. Let me erase my negative slope there. Positive slope here. And I think that's it, just from 0 to 1. Now, when is P at rest? Well, that's when the velocity, or the slope, is equal to 0. So we have 0 slope here, and we have 0 slope here. So from 1 to 2, and that's 3 to 5. Now it says graph the velocity. This is a whole different situation. But it's really not that hard if we break it up into intervals. If we look at it from 0 to 1, What is our slope? Well, let's look. Up 2 over 1, using rise over run. When we look at 1 to 2, our slope is 0. When we look at the interval from 2 to 3, it's going to be a negative slope. It's going to be down to 3, 4 over 1. At the interval from 3 to 5, slope is 0. And from 5 to 6, slope is negative down to over 1. So I can actually plot this. Let me make a nice little graph here. This will be v of t. And what we'll do is we'll segment those intervals off, so we have them real quick. Okay, so from 0 to 1, our slope is 2. Oh, I did that wrong. Sorry, guys. I know it's really. So Lucas is tripping. That's better. So from 0 to 1, our slope is 2. From 1 to 2, I'm going to make this a different color so you can see it. Our slope is 0. From 2 to 3, negative 4. From 3 to 5, this whole part here. And from 5 to 6, negative 2.